Hello, this is lesson 9.1, functions, and what I need you to do first is I need you to copy the title down and then divide your paper into 4 sections. And when you're ready to continue, press play. Please pause now. On the top left of your notes, I need you to copy down what you see on the screen, pause the video to do so, and when you're ready to continue, press play. Please pause now. Now we're going to be talking about functions in this chapter, and a function is a relation where each x has exactly one y. And the word relation means that it's a set of ordered pairs. So I'm going to go ahead and draw a little arrow from the word set of ordered pairs to the word relation. That's what a relation is. Okay, so I want you to copy down the problem that you see on your screen. And this is an example of a relation. And then you'll notice that there are these fancy brackets on the end of them. Okay, that just means this is a group of ordered pairs. And each of these ordered pairs are in parentheses. So to decide whether or not this is a function, you have to look at each of the x values. So the x value is always the first coordinate, and the y value is always the second coordinate of each coordinate pair. So we're going to look at the x value. Here we have a 5, a 6, a 7, and an 8. All the x's are different, so that would just mean that each x has exactly one y. So if you look at the x's and they're all different, that's a big clue. That's automatically going to make a function because you would not have the same x matched up with different y's. So I need you to write that it is a function, and it's because each x has exactly one y. And then we're going to box our answer. Okay, so now let's take a look at problem 2. On problem 2, let's say you were given a table where you have an x and y row, and each of the ordered pairs are vertical. So it's 1, 7, 6, 6, 3, 2, 1, 4. When you look at this relation, you look at the x values again, okay? And if you need to pause the video so you can copy the table first, please do so. So the x values here are 1, 6, 3, and 1. 1 again. Now notice, with the 1, for this ordered pair, 1 is paired with 7, and then this ordered pair, 1 is paired with 4. So I'm going to go ahead and circle those. Okay. So then here, this would prove that this relation is not a function because each x does not have exactly one y. So we can write down below that it's not a function because 1 is paired with 2 y's. And I'm going to go ahead and box our answer. Now on the upper right of your notes, I need you to copy what you see on your screen, pause the video, and press play when you're ready to continue. Please pause now. So in this box, we're going to talk about the vertical line test. And you would use the vertical line test when you're not given the ordered pairs, when you're only given a graph. That's when this is going to come in handy. So I'm going to show you a couple of examples of how to use it on a function. Okay, so I want you to draw what you see on your screen here for problems 3 and 4. The red line and the red dots, those are our relations. So we're going to use the vertical line test to see if they pass the test, and if they do, that means they're a function. Okay, so pause the video if you need to so that you can draw the graphs. And then also, I left some space here because we're going to do some writing here. All right, so for number 3, what we're going to do is we're going to take a vertical line. So I'm just going to pretend, since I can't show you with my pencil, I'm going to pretend I have a vertical line. I'll make it green right here. There we go. Okay, so it has to be vertical. And what I'm going to do is I'm going to pass it across the graph. Okay, notice that that red line only intersects this vertical line 1 point at a time. Okay. So when it does, that means only 1 point at a time. That means it passes the vertical line test. So that means this is an example of a function. So let's go ahead and write function there and then box our answer. Okay, it's a function, it passes the vertical line test. Now let's take a look at problem 2. Okay, so for problem 2, we have, instead of a line, these ordered pairs, these points. Okay, this is our relation. So what we're going to do is we're going to take that vertical line again and we're going to pass it through the graph. Okay, so here it hits this point one time, this point one time, we're good. But then when it hits this right here, notice it hits 2 red points at the same time. Okay, and when that happens, that means it's automatically not going to pass the test, so that is not a function. So go ahead and write that on your paper and then box your answer. Okay, now we're on the lower left side of our notes and we're going to talk about function notation. And if you look up here, equation notation we have done before. We've done equations where we have, it looks like this, y equals 14 plus 3x. Now you're going to see some function notations. Function notation looks like this. It's now replacing the y with this, what we call f of x. F of x just means the function in terms of the variable x. So it doesn't stand for 2 variables. It still stands for just the y value. Okay, so we're going to try some problems. So I need you to pause the video so you can write these functions down. The problem says if f of x equals 14 plus 3x and g of x equals 8x minus 1, find, and this is problem number 5, find f of 4. So pause the video if you need to finish writing this down. And what I'm going to do here is explain how to find that f of 4. So this f means we're going to be using this function rule right here, and we're going to replace the x value with 4. Okay, so I need you to write next to it that f of 4 is equal to 14 plus 3 times 4. So this here is our function notation. We're just replacing, okay, the number 4 in place of x. Okay, so that's what this is right here. And now we're going to solve using order of operations. So what we would do next is you have to multiply 3 times 4, okay, which is 12. So then we have 14 plus 12, and then we add those together, and then we get 26. So f of 4 is equal to 26, and we box our answer. So now let's say for number 6, I want you to write number 6, we're going to find g of negative 3. So that g of negative 3 means that we are going to be using the function that has the g of x. G of x equals 8x minus 1. So we're going to use that rule, and we're going to plug in, we're going to plug in the negative 3 in place of x. So now we're going to have here g of negative 3 equals 8 times negative 3 minus 1. Okay, again, I'm just getting that rule from above here. The g of x equals 8x minus 1. And now here, we're going to go ahead and use the order of operations. So we have to multiply first. 8 times negative 3 is negative 24. Okay, then we bring down the minus 1. And then remember that that minus 1 means plus negative 1. If you do KCC, keep change. And then here we're going to have, this is going to equal to negative 25. So g of negative 3 equals negative 25 is our solution. So right now is a good time for a movie clue. The movie clue for this video is going to be to draw a little boat on the side of this problem here. So please draw a boat before we continue. Okay, so now on the bottom right, I want you to copy this problem down and pause the video so you can copy it down, and then press play when you're ready to continue. Please pause now. Okay, so for number 7, a boat travels 5.5 miles per hour. Write a function that represents the distance traveled in any number of hours. Before we do that, I want to go ahead and first talk about the independent and the dependent variables. So we're going to do a part A. So let's write independent and dependent down below. And remember, a function is going to have two different number values for each ordered pair. So in this case, one of our number values is going to be the distance traveled, okay? And then the other number is going to be the number of hours, okay? So when we look at the distance traveled depends on how many hours has passed, okay? So the dependent variable is the distance. Okay, so let's go ahead and write distance for the dependent. The independent is the number of hours. So I'll go ahead and write that in for independent. Okay, so now for our variables, for the number of hours, we're going to let that be h. Okay, and then for the distance, since we're writing it in function form, it's going to be d of h. So now to write our function for this problem, we're going to write it like this. We're going to say d of h, the distance here of the boat that's traveling is going to be 5.5 times h, times the number of hours. So this is our function. Okay, so we're going to add another part to this problem. And for this next part, we're going to ask how long would it take for the boat to travel 22 miles? So let's write that question down. And so now we're going to use our function. Remember, 22 miles is the dependent variable, the distance. So we're going to write it like this. 22 equals 5.5 h, okay? And then to solve for h, we then have to divide 5.5 to each side. So then h is going to equal 4 hours. So we'll have here 4 equals h. And then I should label 4 hours. And then that's the answer, the last part. Thank you very much. Have a good day. Bye-bye.